Okay, so I'm going to do this third integration involving powers of secant and tangent on this video. And now this one, I warn you, is going to be a rather extensive problem. So see if you can grab a hold and hang on with me as I work this problem. Okay, so we're going to have the integral of secant of x to the fifth power. And what we're going to do is, to integrate this, we're actually going to use integration by parts. And so what I'm going to do is I'm going to think of secant fifth x as written like this. And so let me show you how I'm going to think of it as. So secant to the fifth x, I'm going to write it as secant cubed x times secant squared x dx. And the secant squared x dx is going to be my dv, because I know it'll integrate easily. This will integrate easily to tangent x. So that means my u is going to have to be secant cubed x, and then like I said, my dv is going to be the secant squared x dx. And then when I integrate dv, I'll get v equals tangent x. But when I take the derivative of u to get du, let me show you what's going to happen there when I take the derivative. Okay, so to get du, I have to take the derivative of u secant cubed x. Now, in case you forgot, that's the same as saying secant of x quantity cubed. So if I take the derivative of secant of x quantity cubed, I actually get 3 times the secant of x quantity squared. Then I have to multiply by the derivative of secant x, which is secant x times tangent x. So then when I multiply this secant x times this secant x quantity squared, I actually get secant x quantity cubed times tangent x. And then remember, you can write this, you can put the 3 here and write it as secant of x quantity cubed like this. So finally you end up with 3 times secant of x quantity cubed times tangent x dx. So that's your actual du. And so that was just in case you needed help understanding where I got this from. So that's your du. So now if I use the definition for parts integration, I would do uv, and if you multiply u and v together up here, that would be the secant cubed x times the tangent x. So there's your uv. And then minus the integral of v du. Now remember, v is the tangent x. Alright, so v du would be, that would be this right here, 3 secant cubed tangent x. And so that's the du. And then if you multiply that by v, so in other words v times this, you would actually get tangent x quantity squared. So we'll get 3 times secant x quantity cubed times tangent x quantity squared. I left out the x there, should be an x there. Okay, and then so you're going to have, and then your dx. Okay, so now bringing this over, I have tangent x times secant x quantity cubed, and we know that tangent squared x can be replaced with secant squared x minus 1, and then if we distribute this through, we actually will get 3 secant cubed x times secant squared x is 3 secant to the fifth x, and then 3 secant cubed x times minus 1 will give me minus 3 times secant cubed x dx. Now, so basically, what have I shown you so far? Well, so far, I've shown you that I can rewrite the secant fifth x as this, which is tangent x secant cubed x, minus this integral, which is minus 3 times the integral of secant to the fifth x dx, and then plus this integral. And by the way, it's plus because there's a minus out here, and so minus times a minus is plus. So plus 3 times secant of x quantity cubed. Now, notice that this integral right here involves the integral of secant fifth x. And that's actually the integral I'm looking for. So what I could do now is I could do that little trick I showed you earlier called the foldback rule. So if I were to add this term to both sides, So if you add that term to both sides, it would actually cancel it on the right-hand side of the equal sign. So if I add this to this, it just cancels it, right? And then if I add it to this side, well, that's like saying you have one of those integrals, and now you're going to add 3 of those same integrals back. So now you're going to have 4 of those integrals. And then on the right-hand side, that's going to equal the tangent x secant cubed x plus that last integral that I had, 3 times the integral of secant cubed x dx. Okay, so now to isolate and find the answer for the integral of secant x to the 5th power, I can divide everything by 4, and so now I get that the integral of secant x to the 5th power is just those terms divided by 4. So if you divide tangent x secant cubed x by 4, you get this right here, and then if you divide this integral by 4, we can just say that's 3/4 times this integral. Okay, but still, I'm not finished, am I? I'm going to have to know what secant cubed x is, and then I'm going to have to come back up here and replace this with whatever the integral of secant cubed x turns out to be. All right, so we're going to do this again. All right, believe it or not, we're going to do it again. So we're going to do it again with secant cubed x. Now, my parts integration here, I'm going to think of this as secant x times secant squared x dx. So I'm going to let u be the secant x, and dv would have to be the secant squared x dx. Then du would be the derivative of secant x, which is just secant x tangent x, and I left off the dx there. But so du would be secant x tangent x dx, and then when you integrate dv, you get v, which is tangent x. Okay, so now go to my parts formula. uv would be secant x times tangent x, and then minus the integral of v du. Okay, so what's v? V is tangent x, and what's du? Secant x tangent x. So I have to multiply secant x tangent x by tangent x. So I get secant x times tangent squared x, and then of course the dx is there. Okay, then I can replace the tangent squared x here with secant squared x minus 1. And now finally that will equal this term, secant x tangent x, right? And then minus, if I distribute the secant x, I get minus secant cubed x minus secant x dx. And so now, what have I shown now? Well, now I've shown you that the original integral that I had here, secant cubed x dx, that's actually equal to this term right here, secant x tangent x, and then minus the secant cubed x integral, because I'm going to break that up into 2 integrals, and then we have minus a minus secant x integral, which is this. Okay, now let me show you what we can do here. Remember here, what we're looking for is we're trying to find this secant cubed x. So what I want to do is, notice over here I have minus the integral secant cubed x. Well, what if I add this integral right here to both sides? What if I add this integral to both sides? Well, if I add it to this side, it's just going to cancel it. And if I add it to the left-hand side over here, if I take integral of secant cubed x dx and add an integral of secant cubed x dx, then I'm going to actually get 2 integral of secant cubed x dx. So I'll get 2 of those equals secant x tangent x plus this integral here. And then if you divide both sides by 2, you get this divided by 2 and this divided by 2 equals the integral of secant cubed x dx. But now we have a formula for this integral. The integral, to integrate secant x, there's a formula. It's natural log of the absolute value of secant x plus tangent x. And remember, we divided this by 2 so we could isolate the secant cubed x. So we get 1/2 times that when we divide by 2. So actually I end up with secant x tangent x over 2 plus 1/2 of this natural log divided by 2, and then plus a constant. Okay, now remember above, up here, we needed to substitute for secant cubed x. So if we take this now and replace secant cubed x with what I got right here, okay, then I'll have 3/4 times what this equaled, right, which is this. So I have 3/4 times secant x tangent x over 2, and then plus this term, 1/2 natural log of the absolute value of secant x plus tangent x. And I know I should have put a plus c out there, but just forgot. Okay, and then you multiply this by 3/4, and you get, basically here you'll just get 3/8 times secant x tangent x. And if you multiply this by 3/4 here, you'll get 3/8 times this natural log, and then plus a constant. So finally, we were able to show that if you integrate secant to the 5th x, it actually integrates to this result that actually has 3 terms in it. So it has this term plus this term plus this term. I actually could remove the brackets here if I wanted to. Okay. Now, here's another practice problem if you want to try this one. It's probably not as extensive as the one I just did, and I don't know if you have to use parts or not here. I'm thinking you can probably do this one without parts, but anyway, it's going to be 1/3 tangent cubed x minus tangent x plus a constant, and plus x plus a constant, and that's your final answer. Okay, so now I've got one more video under the guise of trigonometric integrals, and that video is going to be, it's where you're multiplying products of sine and cosine that have different angles.